Okay, I'm using the old phone because the other one's on charge right now. It's all these videos I keep making. I'm still watching Let's Dig. I kind of, I like watching Let's Dig 18 because it doesn't make my brain think about everything, and it allows me to concentrate on my progress. So, hello camera. I'm a mess. I'm tired. So I've been sat here thinking, um, when I built that device, the test rig, it's over there. Put it on the put it on top of the gas fire right now because it was in the way. So I'm thinking that was supposed to be just to test the theory, and I've already proven the theory. And how far could I take that? Uh, the problem is it's the magnets. I can only get so much flux in the middle of the core. And I'm thinking, right, so I can spend a whole bunch of money on copper and um, more 3D printed filament, and at the end of it, I'll still have to build a bigger one. And I thought, well, bugger it, let's just build a bigger one. We want bigger magnets, more power, more flux. So I was sat here thinking about it. Oh, let me just spin the camera around, and obviously I've got these great big 20mm magnets. Oh, these are neodymiums, and I've also got those really powerful flat rectangular magnets. And my gas fire is full of magnets, So I haven't got the light on right now. I don't think there's much point because it's just a little chat. And I thought, yeah, let's just scale everything up in the SketchUp model. Let's just make it big enough, scale it up big enough so that I can get the bigger magnets in the core. I'll show you. I mean, hang on. I'm using the six-legged thing, but what I want to show you is where the holes are. I just need to scale it up big enough so that them holes, instead of taking them little tiny little rectangular magnets, I can stick the big 20mm in. So that's not a big scale up, but I want enough room between the center axis, which is where the hole is in the middle. I want enough space between the bearing, which is in the middle, and the outside edge, so that I can get maybe, well, let's see, how thick are the magnets anyway? Let me just check. Hang on, I've forgotten now. I think they're 2mm. So, get my calipers. I'll just switch cameras again. Hang on. So, these big 20mm magnets, sorry about the lighting, I'm just tired. Let's stick this magnet between my calipers, if I can. I think it's 2mm thick. Actually 2.7, it's actually 3mm thick. Well, 2.78. When I got these magnets, they were supposed to be 3, but something like that anyway. But with them being from China, they seem to don't give you quite what you expect. So some of these magnets are actually thinner than others. So 2.78, let's call it 2.8 because of can't get the damn thing out of here now. Got you. Right, so let's call it 2.8. Right. let me just get my let's get my calculator up. So it's a long way away. I just want to work this out because I'm sat here thinking. So 2.8. Let's say we had 5 magnets or 6 magnets. Let's call it 6 times 6. That would mean I'd need 16.8 millimeters. 16.8 millimeters per set of magnets. Obviously on each side, so that would be times 2, which was 33.6 plus the distance between the bottom of the magnet and the hub and the bearing and all that. So yeah, I'm just doing so. This is just approximate. I'm sorry, you probably can't see on this crappy camera. Yeah. So anyway, I'm being a little bit over. So a little bit. What's the word? Overestimating things at the moment. So let me get my ruler and just see, because I need to visualize that. So if that was 33.6 for 2, can't see this bloody ruler. Let's just be conservative, and plus a hub section. So I would say the hub would need to be around 50 millimeters wide. So this hub would have to be, it's already 50 millimeters, so it would need to be bigger than that. So actually it's the width of the magnet that matters. The width of the magnet is 20 millimeters, so the magnets that are in there at the moment are wide. They're about 10 millimeters, so that's, I need to double that. So this hub would have to be times 2, basically, or times 3. So it would have to be a lot bigger than that. But I would want to keep the where's my drawing again? I would want to keep this, the distance between there and there, the same. So I wouldn't want to scale out. The circumference would be a lot larger, but I want to keep the distance between the magnets that are switching through the core material the same. The reason for that is the bigger the distance, the more losses there is, but the swing, the amount of speed relative, because of the larger circumference, would be faster anyway, but we'd also have more drag. And by having extra magnetism, bigger magnets, it means that we're going to have more output, a lot more output. Yeah, so anyway, I was sat here thinking about it, and I thought, well, it's all about cost and everything. It's about the balance of everything, and obviously I know it works. I just want to scale it all up, and well, I'll scale up the hub, then I'll work out what the maximum diameter of the inside needs to be. Then I would basically model a new drum. I have to realign all this as well, and because we're going to use 6 segments instead, I would divide this into 6, but these laminations that are poking are angled to the right there and angled to the left there. The reason I did that was because the original coil that I was going to use was just one coil in the middle, and I wanted that flux to be directed to the center of the coil. But with the new coils, which are wrapped around the canopies, we don't have to angle them like that. We can have them more or less straight, if you see what I mean. So by doing that, it means that I can have the extra segment in the middle, because we don't want the magnetism cancelling itself out against another segment that was right next to it with a different pole, do we? We don't want that happening. So we would need to, on the ends of these pink areas where the laminations come right to this corner, they would have to be further back, there would have to be a space, it would have to basically stop around there and keep that flux more focused in a straight line for where the coils would be, and then we could be able to squeeze in the extra segments into the blank areas where at the moment where it's blanked. And I would divide that, so what I would do is use my my divisions, you know, the tool that we do degrees in. So I would divide this into 360 degrees. I would divide by 6 instead of 3. So instead of each one of these starting at I think it's 60 degrees, isn't it? 60 at the moment. It would basically be 30 degrees. I think I've got that right. So we would divide it by into, no, hang on, 60. Yeah, 30. I think it's 30, yeah. So I would have to, like a pie chart, I would have to divide it into 30 degree sections or something like that. But the circumference would be a lot bigger, so I would get more segments in. So you get what I mean, anyway. Anyway, so I was sat there thinking about it. I mean, I can keep on winding coils for this thing. Oh, where are we there? I keep on winding coils, and then I'm going to end up having to redo them. You see, you know, and copper costs money, so yeah. I think you can see where I'm going. I just think it's practical just to scale the damn thing up, and I can still use a small motor even so, because I'll just gear it. I'll just gear it down a bit. Oh, yeah, gear it down so that it can still drive a larger rotor, because the circumference will be a larger circumference, but it'll effectively be like it's going faster because of the more segments. So I'm sure that little motor can handle it without any problem, and it's an advantage as well because it doesn't use a lot of power, that little thing doesn't. So yeah, so yeah, uh, so I'll let you know what I'm thinking. So that's it for now, just a little update, and I'm tired, so I'm probably going to go to bed soon anyway. So I suppose this update will be for Sunday. mm. I just like to make sure that I don't keep going down the wrong rabbit hole. I mean, it's not a rabbit hole as such. It's just, yeah, I'm digging down at a small hole. I'd rather it be in a bigger hole, if you know what I mean. I mean, I don't mean it like that. I don't mean I'm in a hole. I mean, you know what I mean. Um, yeah, that's what I mean. I'm tired. I'm not thinking out straight. Anyway, I worked this out by thinking about it all, and then I could start coming out with useless words. But anyway, so yeah, it's just I just don't want to spend a lot of money on this test rig when I'm gonna be having to build a big one anyway, because the limitations are obviously the magnets. I can't get enough magnets in the middle. There's just no room. So yeah. So, okay, thanks for watching. I'm gonna shut up now before I really end up in a real hole. I think I've got it straight now.